This podcast is an introduction to proving trig identities. I discuss the basic process of transforming expressions into equivalent forms, then go through 3 examples. Using trig identities to rewrite expressions in equivalent forms can create simpler or more useful expressions when solving equations. But first, what's an identity? An identity is an equation that's always true, no matter what values we choose for the variables involved. There are a few identities that you have used in the past. A plus 0 equals A is called the additive identity, and A times 1 equals A is the multiplicative identity. Identities are different from regular equations that we would solve. In a regular equation, we would get a limited number of values that work, that make the equation true. For an identity, every number works or makes the equation true. This chapter we will be proving a variety of trig identities. Once we prove one, we'll be able to use it in further equations. Now for the steps to prove an identity. Start by writing the identity to be proven at the top. This gives you a reminder of where we're going. Then choose one side of the equation to transform. This is really important. It won't be a proof if we change more than one of the sides. It doesn't matter if it's the left or the right of the equal sign, as long as we limit it to 1. Then we're going to use our algebra skills, we're going to multiply by fancy ones, and we're going to substitute previously proven identities to transform the chosen side. Your proof is complete when you arrive at a true equation, where both sides look the same. An example of this might be cosine x equals cosine x. Something like that, where one side was manipulated, the other side was not, but in the end they both look the same. Once we get to this point, we want to show that we know that we got there. So you can use a check mark to say that yes, indeed, we did prove the identity. You can use a smiley face, or if you prefer to be fancy, you could use the abbreviation for Latin, QED, which was to be demonstrated. You'll see this QED in a lot of textbooks. We've already talked about a few different identities and properties that might be useful to us this chapter. The first one is the Pythagorean identity. Do you remember it? Pause for a second and see if you can write it before you see what I bring onto the screen. Alright, cosine squared plus sine squared equals 1 is the Pythagorean identity. Now pause again and see if you can use your algebra skills to rewrite it in different forms. See if you can get 3, 4, 5 different ways to write it. Okay, another thing we've talked about are reciprocal properties. These we studied last chapter, but now we're going to start using them when we prove our identities. 1, secant squared equals 1 over cosine. Another, cosecant equals 1 over sine x. And the third, cotangent equals 1 over tangent x. These 3 will be very useful, just like the Pythagorean identity. The third thing that we talked about already are quotient properties. The first deals with tangent. Tangent is the same as sine of x over cosine x, which we can rewrite using the reciprocal properties as secant x over cosecant x. Similarly, cotangent x equals cosine x over sine x, which is the same as cosecant over secant. All 3 of these are going to be the foundation for the first few identities that we prove. It's important to keep these handy so we can refer back to them as we go through the first few proofs. Also, note that I did not discuss here the limited domain for any of the reciprocal properties or the quotient properties. I'm expecting that you have that in your notes already. Okay, now for our examples. We're going to go through 3. I encourage you to pause when you need to, try to do the next step on your own, anticipate what it might be, rewind if you need to. This might also be something good to revisit later if you ever get stuck. Now for our first example. Sin x times secant x times cotangent x equals 1. Before I get started, I'm going to look at the two sides and choose which one I want to manipulate. I want them eventually to look the same. I'm not sure what to do to the one to make it look like sine, secant, and cotangent, but I do have some ideas on how I can change secant and cotangent and hope that something reduces. So first, I'm going to write down the left side that I've chosen to manipulate. So sine x times secant x times cotangent x. Alright. First, the sine x doesn't change. I'm going to leave that alone. Then I'm going to take secant and change it using the reciprocal property to 1 over cosine x. Third, I'm going to take cotangent and use the quotient property to rewrite it as cosine x over sine x. Now, using what I know about algebra, I'm going to multiply through my equations. Oops, forgot an x. So I have sine x times cosine x as my numerator, and cosine x, sine x as my denominator. At this point, I can recognize that anything divided by itself is equal to 1. So this reduces down to 1. Now I have my left side of my equation rewritten as 1, which equals my right side. So my final step is to write 1 equals 1 and choose either to do a check mark, a smiley face, or write the Latin QED. The first example wasn't too bad. Let's move on to something a little bit more challenging. Secant x over sine x minus sine x over cosine x equals cotangent x. Okay, two sides of the equation. I know how to change cotangent x. I know how to change some of the things on the left side with the two fractions. Eventually, I think it might be easier to combine the two fractions on the left to try to get them down to one term, similar to the right side. So let's choose the left side to manipulate. So secant x over sine x minus sine x over cosine x. I'll remember from my algebra that I need common denominators in order to combine fractions. So I'm going to multiply the left fraction by cosine x divided by cosine x. That way I won't be changing anything because I'm multiplying by a fancy 1. On the right side, I'm going to multiply by sine x over sine x. So how does this help us? Oops, a little too far. My denominators are going to now match, and I'm going to have cosine x, sine x on the bottom. On the top of the right fraction, I'm going to have sine squared x, because I had two of them multiplied together. On the left side, cosine x times secant, which is the same as 1 over cosine x, equals 1. So if I combine these, I'm going to have 1 minus sine squared x as my numerator, and cosine x sine x as my denominator. At this point, I should recognize the top as looking like a form of the Pythagorean identity. cosine squared plus sine squared equals 1. If I am to move this sine squared over to the other side, I would get 1 minus sine squared x. Therefore, this top right here is the same as cosine squared x. So I can rewrite this side of my equation as cosine squared x over cosine x sine x using the Pythagorean identity. Now, using another algebra skill, I know that one of these cosines that's on the top can reduce with one of the cosines on the bottom. And I would be left with cosine x over sine x. Now, looking back at my quotient properties, I can conclude that cosine x over sine x is equal to cotangent x, which is what I was hoping to manipulate that left side into. So my final step is to say cotangent x equals cotangent x, and I'm done. So check mark, QED, smiley face, recognize that I made it through my second trig identity. Okay, now for our third and final example. This one's a little bit tougher. There's a lot going on both sides. I have some ideas on things I could do on either side. The left side kind of looks like that transformed Pythagorean identity, and the right side has a lot of different reciprocal or quotient properties that I might be able to use. I'm going to start with the left side. If I get stuck, I can always go back and try some of my ideas on the right side. Okay, so 1 over 1 minus sine x. In order to transform it into the Pythagorean identity, or a form of the Pythagorean identity, I know that I can multiply by the conjugate. And the conjugate is the same terms, but the opposite operation in between my binomial. So again, I'm using that idea of a fancy 1 and another algebra idea of the conjugate. So on the top of my expression, I'm going to have 1 plus sine x. On the bottom, I'm going to use either my generic rectangle or FOIL method, or just from memory of knowing how conjugates work, and know that the denominator is going to be 1 minus sine squared x. If you don't see how that works, I encourage you to pause now and try it. Make sure you understand where the multiplication of those two denominators turned into 1 minus sine squared x. Okay, now that I have the denominator looking like a form of the Pythagorean identity, I'm going to rewrite it as its equivalent form, cosine squared x. This is helpful because now that I have one term in my denominator, I can split this into two fractions, or two pieces, like the result I'm going for. So I'm going to have 1 over cosine squared x plus sine x over cosine squared x. Now, using the reciprocal property, I know that 1 over cosine squared x is the same as secant squared x. That's great. That's looking like what I want it to look like. In the second one, I notice that I've got a sine over a cosine, but I've got an extra cosine on the bottom. So this is the same as sine x over cosine x times 1 over cosine x. So that shows me the two cosines separated, but leaving the one sine on the top with one of the cosines from the bottom. Now this, from the quotient property, I recognize as being tangent. And the second half, 1 over cosine x, I recognize from my reciprocal properties to be secant x. haven't changed my secant squared x, so I'm going to put that in as well. Alright, now I'm to what I was hoping to get to. When I'm multiplying, it doesn't matter which order I write things in, so these two can be switched. And my final step is to write the property secant squared x plus tangent x secant x, let me move it up a little bit, is equal to secant squared x plus tangent x secant x. Great! I got my third and final one completed without too much trouble. To be honest, when I was preparing for this podcast, that last example gave me a little trouble. It took me a couple tries before I finally got to the solution. That'll probably happen to you sometime this chapter as well, so I want to give you some tips to avoid an identity crisis. First, try the other side of the equation. Sometimes that can give you a fresh perspective, give you some ideas of how the identity may be proven. Second, try a different approach. We're going to get lots of different identities that we can apply, so go back and try a different idea. Third, try a different problem. Sometimes looking at another one will give you a strategy that you can use on one that you previously were stuck on. Fourth, don't spend too long. Take a break. Coming back to it with fresh eyes and fresh brain can sometimes be all that you need. Okay, that's it for this podcast. I'll see you next time.